Hi, I'm Donovan, and today I'll be joined by my colleagues Kristina and Mayuri. We're going to share how to create seamless video capture, editing, and playback with CameraX and Media3. As a bonus, we'll see how to add custom effects each step of the way. Let's get started. Billions of users have chosen Android as the platform where they express themselves and connect with others. More and more, these users are looking for new, innovative, and fun ways to express themselves. Today, we'll focus on using our Jetpack CameraX and Media3 libraries to build delightful video creation and consumption experiences. To start things off, I'll cover CameraX for easy-to-implement camera integration into your app. Then Kristina will talk about Media3 Transformer, which handles video editing, transcoding, and more. Finally, Mayuri will go over Media3 ExoPlayer and the options you can set for video playback. Jetpack libraries are flexible, performant, reliable, and consistent. And an increasing number of apps are using CameraX and Media3 every day. In fact, nearly half of the most popular apps are already using these Jetpack libraries for their camera and media needs. So let's dive in and see what these libraries are capable of. We'll look at a number of code examples from one of our hero sample apps, Socialite, which can be found on our GitHub page here. Let's start by using CameraX to capture some videos with effects. We first need to set up the basic video recording. A quick recap of CameraX's structure. You select which use cases your app needs when setting up CameraX. These use cases are preview, image capture, video capture, and image analysis. For our app, we only need preview to show the user what's being captured and video capture to save a video file. First, let's create the preview use case. We'll set our aspect ratio strategy to be a 16:9 ratio. CameraX also supports a 4:3 ratio. Then, we create a resolution selector and set the aspect ratio strategy. There are other options we could set, like whether to prioritize capture rate or resolution. We'll use the default and prioritize capture rate for a smooth-looking preview. Then, we create the preview use case using a builder, like so. To create the video capture use case, we first need to create a recorder. Let's set the aspect ratio to match our preview. And for the quality, we'll choose highest to let CameraX find the best quality supported on a given device. You can specify qualities like standard definition, full high definition, and ultra high definition, but not all of them are supported on every device, so you also need to specify a fallback strategy in that case. Then, we use the recorder to create a video capture use case. To move things along, I won't show all the details of setting up the video output file. Check out the CameraX Foundations video series in this video's description for that full explanation. And with that, we're close to having a working video recording app already. All we need to do to finish setting up the camera is to create a camera provider with CameraX. The await instance method is a suspending function that returns a fully initialized camera provider. Then we'll create a use case group builder and add our preview and video capture use cases. One last thing, before we bind these new use cases, we need to make sure any previously bound use cases are unbound. Then we call bind to lifecycle with a lifecycle owner, a camera selector, in this case we'll use the default back camera, and our use case group, which we build inline here. And that's all you need to set up video recording in your app. Now, I started off this talk by saying users are looking for new, innovative, and fun ways to express themselves. So let's look at how to apply a simple filter, which you can build on to create pretty much any custom experience for your users that you can dream of. The amazing news is that CameraX makes adding effects a breeze with the Media3 effect connector, which is currently in alpha. Kristina will go over more built-in Media3 effects later, but for now, let's add a simple black and white filter. When the effect should be applied, you can create a Media3 effect, passing in the Android context, the use case targets this effect will be applied to using a bitwise OR, an executor, and an error listener. Then you set the list of effects. In our case, it will just be the built-in RGB filter's grayscale filter effect. Then just add the effect to the use case group builder we created in the last section, and we're done. We've applied an effect to the preview and the final video. For my last trick, I'm going to really show off how all of the pieces of CameraX can come together to great effect. Thank you, thank you. This effect will allow me to record what's in front of me, and it will also capture a selfie cutout of me as if I were standing in front of a green screen. We'll start by using CameraX's Concurrent Camera feature to get two camera streams simultaneously. So we have our original use case group builder like before, but we'll create a secondary use case group builder to use the image analysis use case. We'll use an image analysis builder for this. The back pressure strategy is used to handle frames when the application's analysis pipeline can't keep up with CameraX's frame rate requirements. In our case, we're only interested in the latest frame. So if CameraX receives a new image before the application finishes processing, the new image is saved to the same buffer, overwriting the previous image. Then we set the analyzer that will do the processing of the frames. We'll define the Selfie Segmentation analyzer in the next section. Then we create a secondary use case group builder and add the image analysis use case. Now we'll create two single camera configs to be combined in our concurrent camera setup. We've selected the primary camera to be a back camera and the secondary camera to be a front camera. See the code in Socialite to see exactly how we did that. Then we'll pass in our two use case groups like so. Finally, we specify the lifecycle owner for each config. Then we need to update the call to bind to lifecycle to pass in our list of single camera configs. CameraX will handle setting up the multiple camera streams. Next, we need to set up our image analyzer to do selfie segmentation. We can leverage MLKit's Selfie Segmentation API for this, which can separate people in the foreground from the background of an image. Going back to our architecture diagram, we can create a bitmap from each frame that comes out of our image analysis, pass that into MLKit, and get a grid of probabilities that each pixel is in the foreground, which we can turn into a mask to remove the background. Here's the implementation of the Selfie Segmentation Analyzer. Read more about the options you can set in the Selfie Segmentation with MLKit on Android guide linked in this video's description. Inside the Analyze method, we can get the bitmap and the mask to do the green screen effect. The bitmap can be created directly from the image we get off of the provided image proxy. For the mask, we can use the results of MLKit in this success listener. I won't go into the details of this success listener here, so check Socialite for the full code. We're almost ready to see the final result. We can take the bitmap and the mask we generated in the last section and draw the result on the original video using an overlay effect. Similar to the Media3 effect we made earlier, we'll use CameraX's overlay effect for drawing an overlay on top of the camera frames. Then we set the onDrawListener callback to draw on the overlay canvas. Check if the mask and bitmap is null first, because we need them to proceed. Then we use this line to clear the previous drawing on the overlay canvas. We'll set up a paint object to handle the masking appropriately, and if any translations or rotations are needed, apply those with a transformation matrix. Then we're ready to draw the selfie overlay. First, draw the bitmap, which has all of the pixel data, then draw the mask on top of it, like so. All that's left is to add the green screen effect to our original use case builder, which has the preview and video capture use cases on it. So you can see my segmented selfie being drawn on the preview and the output video. With only my selfie being drawn, it frees up a lot more of the main content to be visible. And what a great view! When implementing your own effects in your app, Just remember that everything that applies to the camera has to happen in real time. A general rule of thumb is that you have 30 milliseconds between frames if your video is running at 30 frames per second. For higher frame rates, you would have even less time. But there's good news, because next you'll see how to apply effects to already existing videos where there are no real-time constraints. Over to you, Kristina.
Sounds like it's Media3 editing turn in the spotlight. Now, what happens after the recording stops? How do we take that footage and transform it into something extra compelling? That's where Media3 editing capabilities come into play. Media3 provides a set of APIs that allow you to edit media content. These APIs can help developers with a range of capabilities. Effects is where the creative magic happens. Media3 provides a powerful and highly customizable APIs to create effects that you can apply to your video. Preview is where you can see your edits in real time. And once you are satisfied with your edits, the export function allows you to render the final video. We will not be covering the export APIs in this presentation. Please check Media3 Developer Guide for more details. Now, let's focus on the heart of video creation, Media3 effects. Media3 offers two approaches to applying effects. Built-in effects are designed for efficiency and ease of use. They handle common video processing tasks like scaling, rotation, and lookup tables. Custom effects are more advanced and specialized. This approach provides incredible flexibility and control, but does require OpenGL knowledge. Now, let's begin with built-in effects. These are the essential tools of Media3 editing capabilities. Let's see a practical example of applying a built-in effect. On the left, you can see a video clip with an RGB adjustment effect applied. And here on the right, you can see the code snippet that achieves this effect using Media3. We start by creating an edited media item from our video URI. Then, we use the setEffects method, passing in an effects object. Within this object, we specify that we want to apply an RGB adjustment effect. This simple code is all it takes to enhance the visual appeal of our video using built-in effects. For a full list of built-in effects, follow the short link presented on the screen. Now, let's move on to custom effects. With custom effects, you can unlock the full potential of Media3, allowing for truly unique and specialized video manipulations. When working with custom effects in Media3, you will primarily interact with GL Effect and GL Shader program. As you can see from the interface definition from Media3's source code, GL Effect acts as a factory. The draw frame method is the core of your custom effects rendering logic. It's invoked for each video frame, receiving the OpenGL texture containing the output from the previous effects stage and the presentation time. Crucially, base GL Shader program handles texture and frame buffer management, allowing you to focus solely on the rendering logic within draw frame. Let's illustrate how to apply a custom effect with a practical example, a vignette. On the left, you can see a video clip with this effect applied, creating a darkened border around the edges. And here on the right, we define a GL effect using a lambda expression. This lambda returns an instance of our custom shader program, which we have created to apply the vignette. This demonstrates how GL effect allows you to encapsulate your custom OpenGL shader programs, making them easy to apply within your Media3 editing pipeline. Now, for a more advanced and visually striking example, let's explore style transfer. To create a style transfer effect, we are leveraging the power of LightRT, Google's runtime library for running machine learning models on device. On the right, you can see the artistic style we want to apply to our frames, and the result, a video clip with a style transfer effect applied to the left part of the video, transforming its visual appearance. By combining Media3 video processing capabilities with LightRT's machine learning power, we can achieve complex and visually stunning effects like this. Now, let's look at the specific pixel processing for our style transfer effect. We have created Style Transfer Effect class that implements byte buffer GL effect processor. To ensure smooth and efficient video processing, we perform the style transfer operations asynchronously. This is handled by processImage method within our Style Transfer Effect class. As you can see, processImage takes an image object and presentation time as input. It returns a listenable future indicating that the processing will occur asynchronously and will eventually produce a bitmap representing the styled frame. After the asynchronous style transfer processing is complete and the effects pipeline is ready to render the frame, the finish processing and blend method is called. And with that, we have explored the power of Media3 custom effects and how we can combine it with tools like LightRT to create powerful video effects. Now, let's talk about the vital step of previewing our edits. To simplify this process, Media3 introduces the Composition Player API. Composition Player is designed to streamline the implementation of previewing media edits. It allows your app to play a composition of media assets, effectively rendering all applied audio and video effects in real time. This means you can see exactly how your edits will look before exporting the final video. It's important to note that Composition Player is currently in early preview and represents the first introduction of this API. We are actively working on its development, so expect further enhancements and refinements in future releases. Composition Player offers real-time preview of complex media edits, allowing users to fine-tune their work before finalizing it. It is built upon the familiar Media3 player interface, and you can use the same composition for preview and export. This API streamlines the editing process, allowing users to iterate quickly and confidently, knowing that their preview accurately reflects the final exported video. Let's look at the code sample. First, we create our composition object, which encapsulates our edited media assets and effects. Next, we instantiate a composition player using the builder pattern. The crucial difference lies in how we set the media source. Instead of using set media items or set playlist, we use set composition to provide our composition object to the player. Finally, we call prepare and play to start the preview. Now, let's see Composition Player in action with a final preview. On the right, you will see a video clip demonstrating the preview of a composition with several effects applied. Composition Player allows us to preview all of these effects seamlessly, ensuring that the final output matches our creative intent. This is the culmination of the editing process, where we can fine-tune and confirm that our composition is ready for export using Transformer APIs. I'm pretty happy with how this video turned out. Mayuri, can you help us with the next step?
Of course. Hi there. Donovan and Kristina showed us how to capture, edit, preview the videos with effects. Now you might want to share and watch it with others. And that's where we can use the Media3 ExoPlayer for playback. For more than 10 years, the open source ExoPlayer library, now integrated as a part of Media3, has been a recommended solution for everything Android playback. ExoPlayer is designed for efficient real-time playback. It's quick and easy to set up ExoPlayer with only a few lines of code. Generally, you'll need to provide a media item or a list of media items that references a media source like a URL, local file, or content URI and prepare it for playback. Is there anything that stands out to you in this code snippet? We're thrilled to announce the new Compose artifact for ExoPlayer, introducing the Player Surface. Check out our documentation for more details. Please note that this API is currently in early preview and represents its initial release. We are actively developing it, so expect further enhancements in future releases. ExoPlayer's capabilities extend even further. We are very excited to share that you can directly set effects within ExoPlayer itself. It provides you with a Set Video Effects API, a method for applying real-time playback effects, usually on the entire video. How awesome is that? You apply these effects to ExoPlayer instance using the Set Video Effects API method, passing a list of effect objects. ExoPlayer takes the currently loaded media item or the active media item in a playlist, decodes its audio and video streams, and then applies the configured effects during the rendering process. The Set Video Effects API allows you to set a list of effect objects that will process all frames as their output from the player. For example, here we set a single effect that improves contrast to help with accessibility. You can create these effect objects using the respective builder classes. If you have a playlist of media items and you set effects on ExoPlayer, those effects will generally continue to apply to subsequent media items in that playlist, unless you explicitly change or clear the effects using Set Video Effects API again. Donovan and Kristina showed us a bunch of Media3 effects throughout this talk so far, and you can try them out by adding to the effects objects in a list. And of course, as well as applying effects during playback, videos exported from CameraX and transformers are playable with ExoPlayer too. So, you've created, previewed, and edited your videos. How do you view and share them? You might wonder, why do we have two players to view, ExoPlayer and Composition Player? Let's see, when should you use which one? In Composition Player, you need to work on a composition, whereas in ExoPlayer, you work on a media item or a playlist. In Composition Player, effects are set on each item or composition, whereas in ExoPlayer, effects are set onto the player, thus will be applied on each media item in the playlist that you're playing. Last one is the timeline. In Composition Player, the progress is calculated based on the duration of the set composition. Whereas in ExoPlayer, the progress bar is tied to the currently playing media item. Wow, that was a lot of interesting and cool stuff. The main key takeaway that we would want you to take back is that CameraX and Media3 work seamlessly together, and we highly recommend using these to Android developers. For a quick recap, we can do capture, analyze, preview, editing, playback with all of CameraX and Media3 effects, all seamlessly with one cohesive solution. First, Donovan walked us through using the Jetpack CameraX library to capture some footage and apply effects to the video in real time, such as the grayscale effect or a green screen effect that uses both the front-facing and the back-facing cameras of the device at the same time. Next, Kristina showed us how to use Jetpack Media3 transformers to add some extra magic to the video with built-in effects, like the RGB filter, custom effects like a vignette, and even more advanced frame processing like style transfer powered by LightRT. And lastly, after previewing and exporting our final edited video, we saw how to use the Jetpack Media3 ExoPlayer to play the videos in our Compose First UI and apply a final round of effects like adjusting the contrast if desired. And look at what we were able to create: capture, edit, preview, playback, all in one. They all come together to create a pretty cool end-to-end journey, isn't it? That's also the key takeaway that we want to give you for this talk. CameraX and Media3 work seamlessly together to help you build amazing apps very easily on Android. Delighted? We are too. How do you go on building these experiences? So, here are our top 3 recommendations that you could go back and do after we sign off from this talk. First, check out our hero sample app Socialite on GitHub to see all the features we talked about today and many more in the context of a social media app. Second, visit the Media3 GitHub repo and explore both the composition demo and the effects demo app for more examples on how to use the effects framework. There are some pretty cool demos right there. Last, check out our guides and documentations in the Camera and Media Developer Center for more tips on how to supercharge your Android apps. We can't wait to see all the cool and amazing effects you build in your Android apps to delight your users. Thank you for tuning in. Bye-bye.